Hello, understanding water treatment processes can be somehow confusing. So let us discuss how to deal with any type of water treatment process. And by end of this video, you will easily understand any type of water treatment process, regardless of its origin or ultimate intended use. Whether it is municipal water like potable water, municipal wastewater, sewage system, industrial water used in industrial processes, or industrial wastewater generated as a byproduct in industrial process. Let us start and take a step back and look at the fundamental concept of water treatment. For a starter, how does water treatment work? Water treatment is the process of transforming the initial analysis of source water into the desired analysis of water to meet specific goals. In a sense, it involves converting the quality of the input water to the desired output quality. We will follow three steps to establish any water treatment process. First step, identify and understand the water contaminants. What are the contaminants that are present in the water? What are their properties? How do they affect the water quality? Second step, select appropriate removal methods. There are many different types of removal methods available. Which methods are most effective at removing the contaminants present in the water? Finally, integrate the removal methods. Once you have selected the appropriate removal methods, you need to integrate them into a process that will reduce the desired water quality. The process should be technically efficient while also being economically feasible. All contaminants, whether in water or wastewater, are categorized into 5 different groups: settleables, floatables, dissolved, colloids, microorganisms. The first category is settleables, which are solids particles that sink to the bottom of the water after a reasonable amount of time. For example, sand, clay, which can originate from soil or human activities such as construction. The second category is floatables, which are contaminants that floats to the surface of water in a reasonable amount of time. They can be sorted in main 3 groups: organic particles and fibers, oil, grease and fats, and gas bubbles. The third category is dissolved materials, which are contaminants dissolved in water that cannot be seen with the naked eye. There are 3 groups of dissolved material: dissolved ions like calcium, magnesium, sodium, dissolved molecules like organic compounds, and dissolved gases like oxygen, nitrogen, and carbon dioxide. The fourth group is colloids. They are contaminants whose particle size falls between dissolved material and suspended solids. The final category is microorganisms, which are living organisms that can cause disease. Pathogenic microorganisms include bacteria, viruses, fungi, and protozoa. Understanding these categories of contaminants is essential in selecting the right removal methods and combining them to reduce the desired water quality. Now, let us consider the methods by which each category of contaminants can be effectively removed. This can involve mechanical, chemical, or biological methods depending on the specific contaminant and its properties. First, mechanical treatment is a physical process that involves the removal of large particles and suspended solid from water. This treatment method typically involves processes such as screening, sedimentation, and filtration. The goal of mechanical treatment is to remove the visible impurities from the water, making it easier to treat with other methods. Chemical treatment. It involves the use of chemicals to remove contaminants from water. This treatment method typically involves adding chemicals such as coagulants, flocculants, to the water, which causes impurities to clump together and settle out. Chemical treatment can also involve the use of disinfectant to kill bacteria and other microorganisms in the water. Biological treatment. It involves the use of living organisms to remove impurities from water. This treatment method typically involves using bacteria or other microorganisms to break down organic matter in the water. The microorganism consume the organic matter and convert it into harmless compounds such as carbon dioxide and water. back to the 5 different groups: settleables, floatables, dissolved, colloids, microorganisms. Let us discuss the method of removing for every group. Settleable removal. The designer must determine the cutoff size for each particle removal unit as the primary parameter for effective particle removal. The methods for removing suspended solid can be broadly classified into 2 principles: sedimentation, based on differences in density, and sieving, based on differences in particle sizes. Sieving can be further divided into 2 types: screening and filtration. Bear in mind that in both filtration and sedimentation, the aim is not to remove suspended solid, but to concentrate them into a stream of disposal. Floatable removal. The 3 groups of floatables and their respective removal strategies can be summarized as follows. First, organic particles and fiber. These can be effectively removed through sedimentation, filtration, or screening methods. Oil, grease, and fats. These can be removed through filtration, adsorption, and screening. Screening is a method of removing floatables based on the differences in density, while filtration is based on differences in globule size. Adsorption is particularly useful when oil globules are very small or even in a dissolved form. Gas bubbles. There is no need for any separation method as gas bubbles separate on their own very quickly. Dissolved materials removal. The removal of dissolved materials can be categorized into 3 groups: dissolved inorganics, dissolved organics, and dissolved gases and volatiles. Dissolved inorganics. Inorganic ions are usually in ionized form when dissolved in water. Total ion removal method is used like reverse osmosis, ion exchange, and evaporation. Specific ion removal methods is used to remove particular ions like removing iron. Dissolved organics. Granular activated carbon or ion exchange system can be used to remove organics from water with low organic levels. Evaporation or combustion methods can be used where BOD is more than 100,000 milligrams per liter. Traditional chemical oxidation and advanced oxidation processes can be used when BOD or COD is higher than 50 milligrams per liter but lower than 50,000. And the COD-BOD ratio is not in favor of biological methods. Dissolved gases and volatiles. Dissolved gases or volatiles liquids can be removed from water by considering them as strippable components or dissolved materials. Stripping can be used to remove easily strippable components. Scavengers, which are chemicals that react with dissolved gases or volatile liquids, can be used to remove dissolved material as well. Colloid removal. There are 2 ways in which colloids can be removed: direct method, converting method. In direct removal, this can be achieved through carbon adsorption or membrane filtration. Granular carbon adsorption units can only remove hydrophobic colloids, while ultrafiltration or microfiltration system can remove colloids with greater efficiency. Direct removal is generally practical when the concentration of colloids is low, typically less than 10 to 15 milligrams per liter. Converting colloids by converting them to suspended solid and then removing the generated suspended solids. This method is commonly used when there is a large concentration of colloids, typically more than 20 milligrams per liter. Finally, dealing with pathogens. The management of pathogens involves several methods, including killing them, destroying their reproductive system, or removing them altogether. Pathogens removal can be achieved through mechanical methods such as ultrafiltration or nanofiltration, where the membranes can remove the pathogens. Precipitation and co-precipitation methods can also remove a portion of the pathogens. A more advanced method for dealing with pathogens is the use of UV radiation, ultraviolet. UV light destroys the reproductive system of the pathogens, leading to a decrease in their population until it's ultimately eradicated. Now, before the implementation of any treatment method, when facing with any contaminant, the first action should not be treatment. Why? because the proper, efficient water management procedures include various methods that should be implemented before treatment, including reducing and segregation. Reducing this concept involves reducing water utilization by a user from the source, while segregation, this refers to practice that avoid mixing high concentration wastewater streams with more diluted wastewater streams. In many cases, treating a highly concentrated wastewater stream is less expensive than treating it after mixing it with a high flow rate and a diluted wastewater stream. By implementing the reducing and segregation, it is possible to reduce the need for treatment and minimize the potential for contamination. Now, the final step is selecting and combining multiple removal methods to achieve the desired quality of product water. To develop a string of units for the removal of contaminants, the following considerations should be taken into account. First, determine whether each contaminant should be removed in a dedicated unit or in a several units. Then consider the suitable sequence of contaminant removal. Finally, identify the provisions that should be considered to protect each selected unit, including pre-treatment and post-treatment measures. From a technical standpoint, separating different contaminants should be done in a separate dedicated units. However, in practice, efforts are made to merge units together as much as possible to reduce project costs. Units can be merged together if it is technically feasible and if the load on dedicated units doesn't increase by more than 20 to 30%. It is worth noting that each single equipment may be capable of removing more than one contaminant, and this should be taken advantage of when developing a string of units for contaminant removal. By optimizing the use of equipment, it may be possible to reduce the number of units required and minimize project cost. That's it. Thank you.